Hey everyone, welcome to today's live stream. We hope you're all staying well and we hope you're all well in these unusual and difficult times. So same thing with us. If you haven't had a live stream with us before, my name is Richard Stubley. I'm a process specialist. I work out of the Birmingham Technology Centre, a technology centre that Autodesk have few across the world, and we're one of the ones in the UK. I'm on my own at the moment in here. I've got guards all up around me because I haven't got a mask on. So if I don't wear a mask in the tech centre, I'm allowed to not wear one if I have guards all up and around. So it's quite a lonely place at the moment. I feel like I'm in like a perspex pen. But yeah, we've got Spencer on the call as well. Go on, Spence. I'll let you introduce yourself.
Hello, everybody. Good to be back. It's been a while since I've been on a live stream, so glad you're all in. Let us know what's going on in the chat. For the new members of the live stream, Spencer Hardcastle, based in the north of the UK. Same team as Rich, so process specialist in customer advocacy, making sure that what gets developed in the software has the interests of the customer at the centre.
Perfect. And again, we've got two or three bits of audio kit. We've got two or three cameras rigged up today, so please let us know if anything's not going well. We, of course, get limited feedback on our end of what we can see, so we sort of have to do this a little bit blind, so to speak. We hope some of you joined in our how to set up a milling machine a couple of weeks back when we had Dylan on the call. There was one request for how to set up the second side of the part, and that's what we're doing today. We've also got another camera set up to get some real close-up shots of the machine. That was some of the feedback we had from the last one. It was to change some stuff with the audio and get a second camera. Again, we listen. We love the feedback, and hopefully we're making these live streams more valuable for everyone. So please let us know any problems with the audio, any problems with the video. We'll do our best to solve it. Otherwise, we'll just crack on. How's the chat looking, Spence?
Chat's looking good. Akash is joining.
Oh, hey, Cash.
Hi, Akash. And Mamadou is joining
Oh,
from
there we go.
Senegal.
There we go. Yeah, where is everyone joining from today? So we've got myself, I'm in the heart of Birmingham in our tech centre. Spencer's up in the frosty north. Um,
Yeah, just outside Leeds in the north of the UK, near Manchester. People probably know Manchester.
yeah,
And Rich is in Birmingham, UK, not Birmingham, US, of course.
yeah, definitely. Right, everyone. So let's just dive into this. So this is a bit of a plug for myself as well. So let's just go over to our different camera, and I want to talk about something. So we all know that Autodesk University is coming up very quickly, and I'm running with two of my colleagues a very unique session. We are running a live factory experience. So for those of you that don't know, AU this year unfortunately can't be in person. It's not in Las Vegas. I might have even met some of you last year at the factory experience there, but it's virtual this year, and we wanted to try and not lose out on the personal touch that we love so much at Autodesk University, and we love taking machine tools and showing you what they're doing. So we're running 7 sessions. It's called the Live Factory Experience. 7 sessions to cover all different time zones. So me and Pete and Jacob are the poor ones having to start at 7 o'clock in the morning and work till 7 o'clock at night to make sure no matter where you are in the world, there's a suitable time for you. And what we're doing is showing you how to design and make these really cool looking laptop stands. So the laptop arms have been generative designed, and then we've 3D printed the other bits of it. So we can see a little bit more about the design here. We've even got some custom engraving on the parts there. And then the best bit that any of you might have been to AU before, we normally let you assemble your own air quality sensor. So you actually get to take away from it all as well. You see the machines that make them, and then you get to take it away as well. We had the crazy idea, why not actually post these laptop stands out to people? It's got approved. There are 250 billets of material waiting for me to machine. I've got through about 100 of them so far. So in the description, there is a link to register for AU. There's a link to add to your calendar your preferred generative design laptop stands webinar, your preferred time. And then there's also a link to a Microsoft form so you can give us your details and we can post you out a laptop stand. Now, there's only 250 or 210 laptop stands up for grabs. Although I've got 250 billets, 40 of those have already gone, so 210. laptop stands we have to give away. Of course, we're hoping there's going to be more interest than that. So we're going to do a random draw at the end of each session, 30 in each session, 7 sessions. So please sign up, come and join in, and you could be one of the lucky 30 to actually get yourselves a laptop stand. I mean, even to the point of we are engraving people's names in, or not names, but whatever 10 characters you like, we're engraving those into the sides of the laptop stands as well. So let's just crack on with today's session. So that was my little plug about the AU session I'm doing. I hope all of you are going to do AU this year. Sometimes it's a little bit difficult to get a week off work to go to Las Vegas, but the fact it's all virtual and on demand, hopefully you can spend some time. So right, what are we doing now? I'm machining these arms. So these arms need to be nicely machined, chamfered on both sides so it's nice and smooth. And how am I going to do that? So I've got 2 operations on our machine. So let's have a quick look at our machine here. Again, unfortunately, I have to be the cameraman and the presenter here. So let's try and bear with me on this one. So let's bring this a little bit closer. So we've got enough space on our bed here for 2 operations. We've got a Lang vice holding our operation 10. That's on the left here. And then we're going to flip that over into some custom work holding in operation 20. So let's go right in close to have a look at what we've got on the machine now. So we can see we've got operation 10 on the left here, and then we're going to flip that over into our operation 20, which is a custom fixture. We'll see how we've made it and look at some of the work holding points on there as well. So that's what we've got set up on our machine. We'll be machining those in a few minutes, but let's quickly take another look at the different operations we've got. Again, sorry this is a little bit clunky. I'm having to be the cameraman here and the presenter because we don't want anyone close to me while I'm not wearing a mask. So this is the raw billet of material we're starting with. Solid billet of aluminium or aluminum, which I must say. We're then going to do operation 10. Now operation 10 is going to machine the following. So it's going to cut out a valley all the way around the part, and it's going to also machine these datum holes that you see here. So it's going to face everything off, so we've got a nice face. Of course, you know, the face that we get from the steel mill is not as nice as what we're going to want. So we want to hold it and completely face that off. And then the big thing here is I want to chamfer this. So I've actually done a 2D contour, made a valley around my part so I can then chamfer that edge. We'll look more about that when we look in Fusion in a second about how that was done. And then of course I've drilled my datums for my second operation. So any of you that have ever done any bespoke work holding before will know one of the most important things is what datums do you use and how do you datum the part. We then do some window machining or some tab machining. So what happens then, when it's flipped over into operation 20, I go round and I use a 4mm mill and slot out the whole profile. And hopefully you can see here some of those little tabs that are left on that just hold the part in place. Those are really easily just snapped off then. So they're snapped off, and what I've got left with is 2 components that can be completely removed from our part. They're chamfered on both sides. They're also engraved on both sides. So, you know, this was quite an interesting part to do. So let's have a look now into Fusion. We're going to see the approach that we took and talk about some of the considerations that you might need to do while you're doing that. So while I'm quickly walking over there, hit some questions up in the chat and we'll try and answer them throughout this session. We want this to be as interactive as possible, everyone. So please, I'm not saying it's your fault if it doesn't go well, but we need you to play your part and jump in on the chat as well. Spencer's laughing at me there, insulting the punters.
Absolutely not. We got some decent chat coming through. Stuart from Hull. We've got Ice Cream is on board.
Oh, hey, Ice Cream.
Steve from North Carolina in the US. Dominique from Belgium. KMS from Germany. And then Stuart was interested to know he's registered for Autodesk University, but didn't know what times the sessions are. Is a way to schedule in advance. And I just said if you log on to your AU portal or account, you can click on sessions and register for whichever one you want. If you do a quick search for laptop stand, you'll find
so the link in the link in the chat will send you through to this page here. And then you can see there's all different time zones. So 7 a.m. is going to be an early start to me. Bear in mind, I live an hour away from the office. So that means I'm leaving my house at 5:30 to get here for 6:30 to then be ready for 7. So we've got all different times across 2 days. Whichever one you want, bookmark it and add to your calendar. So add to your calendar downloads I'm not sure what they're called, but it downloads something that goes into Outlook and puts it in your Outlook calendar as well. The second thing is if you would like to be within the chance of being one of the lucky people to get a laptop stand, there's a Microsoft Forms here, just with basically, we need the details to post the thing to you. So your postal details, there's 3 different options on the height that it will lift the laptop stand for, and then you're allowed 10 characters. So we'd really like, I've got 210 to send out, and I intend to send out every single one of them. So hopefully some people on this call will end up getting one.
Absolutely brilliant. Hope that answers your questions, Stu. We've got the infamous Al Watmore on the call as well.
Oh,
Hi,
well,
Al.
how's it? Hi, Al.
Prodigy's here. Victor from Indonesia. Iego, sorry if I butchered that name, from Brazil. And Udian as well.
Okay,
Hello, everybody.
perfect. Right, so let's crack on with the session again. Sorry, I keep diverting into my AU session. It's not about this. This is about how to machine the second side of a part live from our technology centre. So what you can see here is a really nice representation of my machine. I mean, this is just the power of integrated CAD CAM. So you've got to think what I've got here now is I've got everything I need here to actually make my part. I've got my vices, I've even got my base plates, got my stock, got the bespoke work holding that I've got here, and then I've even got my tool length probe as well, because, although it's not really that important for Fusion to know about, it's very important if I try and machine the top of it off with my facing mill cutter. So you've got to think any obstacles, anything that you don't want to hit, how important it is that you actually have this in your CAD view here for your representation. I mean, this is the power of Fusion with integrated CAD CAM. So what I've got 2 operations. Let's have a quick look at operation 10. So you can see I've even got machining the fixture. I've got the 120mm laptop stand operation 10 and operation 20. So if I click on that there now, it's going to change the parts. So if you watch closely again, I'm going to go to 140. These parts will change. Those parts will change. Ready? There you go. There's 140. There's 120. So you can see the parts are changing all the time. So I've got something on here that's called synchronize view with active setup. So what that means is every time I change setups, it's going to actually synchronize the parts that are visible as well. So 140 operation 10, what are the toolpaths that I've applied here? I've got some probing because my name's Richard and I do probing. Everyone knows me, knows I do probing. But what the important thing for this probing over here is that I'm just putting that block of stock material in our vise. I can't be 100% exactly where it's located. And let me go and grab one of those windows that we're machining out. You're going to see how little material there is on here. So what you can see here, how small a gap of material. I've got a really fine margin for error there. If I'm too far to the left or the right or front back, I'm going to definitely have problems with non-cleanup. So that's why I'm doing some probing first. Again, I've got 210 to make of these to hand out. I need to make sure that every one of them is right. Next thing, facing pass. I'm not going to start talking about how we do facing passes. Hopefully, those of you have seen our intro to CAM videos where we talk about these real bread and butter toolpaths that everyone needs to use. Next thing is some engraving. So hashtag AU2020. This is the social media tag for AU2020, and hopefully everyone out here is going to be posting about how much of a good time they're having at our virtual AU event. But I want to talk about the tools I'm using for this. I see a lot of people who use V-groove cutters for engraving. That is brilliant in materials like wood and perspex. But when it comes to metallic materials, personally, I find a 1mm ball nose gives me really nice engraving. So that's just my experience, especially going into aluminum or aluminium. A 1mm ball nose really helps. again, I should stop digressing, but back when I used to work in a forge in the heart of the West Midlands, we used to have to put the cast code into the dies, and we'd use 1mm ball noses to do that. It just tends to give a bit of a nicer surface at the bottom, because the problem you've got with a V-groove tool is that bottom is really weak. Just by the nature of the fact it's going down to nothing. So when you're using harder materials, we can have problems. Right, now, this is where it gets a little bit interesting of what's going on here. What I really want to do is chamfer these edges. So let's quickly simulate if I was to just do the facing and the chamfering, let's quickly see what would happen here. So what's going to happen, I'm going to press play, it's going to go around, it's going to do my facing for me, and then it's going to do the chamfering. Let's try and pause this at a good point. And anyone who's done machining knows that that cutter is not going to last 10 minutes. It is just going to snap. You know, it's got full engagement on both sides of the tool. That tip's not going to be very happy with me for doing that to it. So what I'm actually doing in Fusion now is I'm doing a contour pass around the whole part with a small stock to leave applied. So I've got a stock to leave applied here of 0.15 millimeters, and I'm going down 3 millimeters into the part. Sorry, 2 millimeters actually. So I selected the contour, went down 2 millimeters. And what that's going to do, that's going to create me a lovely channel that my chamfer mill can do the engraving with. So let's have a quick look at this. So I'm going to do my facing. Let's skip that operation. I'm then going to go and do a grooving pass, or a slotting pass almost, with a 2D contour. And this is just creating me that valley. So really, I don't want to do this. It's wasted time, but I need to do it to get that chamfer exactly where I want it to be. Because I'd rather waste the time in doing this operation here than what I would have in operation 30, where I have to then flip the part back over again to chamfer the two sides. So these are all considerations you have to do when machining a part of two sides. You have to think about, how do I access both sides of the part? What features do I need to machine in operation 10? What features do I need to machine in operation 20? So that's the thought process that I go through. I've got like a tick list in my head of all the surfaces, and I go, right, I'm going to get you, and you in operation 10, and I'm going to get all of you in operation 20. So we can see now I've done that valley all the way around my part, and that's going to give a really nice space now, as you can see, for my chamfering tool to come down and actually machine on there. So we can see here that now I'm going to machine away my chamfer on the part. So be interested in the chat if anyone's done anything like that before. Has anyone ever made like a sacrificial toolpath to go and clear the way for another toolpath to come around? I was quite proud of myself when I thought of this option, but maybe I shouldn't have been. So that's what we've got on there. And now an important thing that the eagle-eyed viewers amongst us would have noticed is, why did I apply that stock to leave of 0.15? And that's because when you change from operation to operation, there's always going to be a degree of error. And when I mean operation, I mean machining operation. So this is operation 10, or setup, whatever you want to call it. And then this is my operation 20, or my setup 2. However you want to call it, we're just down to terminology there. And then there's always going to be a degree of error when I flip between this side and this side. And I would get a step between those two contours if I was to machine the first one completely to size. So leaving that bit of stock to leave means that when I flip the part over into operation 20, I've got I've got 0.15 room for error. So if my part's 0.15 out to the left, it doesn't matter because I've got that stock to leave applied from the previous operations, so I can do a full clean up pass all the way around. Fingers crossed that made sense. Let me know in the chat if not, and we can revisit it. How are we doing in the chat at the moment, Spence?
We're doing good. There was a few complaints of audio,
Okay.
a little bit of an echo, but still totally understandable apparently. So
I mean,
I would probably put
Pat,
that down to your location, to be
yeah,
honest.
I mean, although I've just told everyone in the workshop I'm doing a live stream, Pat has just been there angle grinding about 4 meters away from where the camera is. So that might have been what you were hearing. I gave him some evils and he still didn't stop. So sorry if that was what was causing the problem.
No, like I said, it's still completely understandable. We've got people joining from Japan,
Wow.
India. A question for you: does the process you just explained work okay for smaller inner radius corners?
Yep. So as long as the radius is small, is larger than the tool. So I hope all of you have seen this minimum radius analysis. So what this allows you to do, if I just select these two bodies here, this shows me. So if I put in 2 millimeters, this shows me in green any radius that is above 2 millimeters, and in red any radius that is below 2 millimeters. So, or at 2 millimeters and below. So what I might need to put 1.99 in there. You can see that there are a few, and then you can just have a little play around and have a quick look at how you've got. So what I've got here is 1.7 on there. So that radius there is 1.7 millimeters. So you can use this minimum radius shading to find out what is the smallest tool I need to get in an area. I mean, you can see there that I'm going to need a smaller tool to really pick that out. Let's go, if it's even smaller than 1. So 0.1, 2, 3, 4, there we go. So I need a point 0.8 tool to go in there, and I'm never going to do that. So I now need to potentially ask my customer for a concession that I cannot machine that small radius. Can we do a design change? Can we do an edit? So it's really nice, this minimum radius shading. You can quickly go over your part and see how machinable is it. Are there any big problems that you need to look at on there? I hope that answers the question of does it work on small radiuses? But again, everyone, please reply. Spencer, you're muted.
All of that analysis, all those analysis features are really, really useful.
Yeah.
The minimum radius, the slope, the undercut detection stuff, all really good stuff. We've got Italy joining. We've got I've already mentioned Mamadou from Senegal, Western Africa. We've got a question. Looks as if the chamfer can machine a much smaller radius compared to the end mill that's used to do the slotting.
Yes, it can, because of course, as you go up on that V, your diameter of your chamfer mill gets smaller. But what we need to do here is I don't, because I'm using a 4 millimeter emerald to go around, I know that I'm not going to pick out that pocket completely. I'm just not going to. It's not going to happen. It's even worse on this one we see here. So what we've got on the 120 millimeter part is I've got my contour running around here, and then I've got my chamfering pass running around again. And on my chamfering pass here, I've got a tip offset. So it's going to drop that tip down 1.6 mil. And what I'm trying to do here is I'm trying to actually make the diameter cutting of my chamfer tool the same diameter of the tool I slotted with. Because let me change this now to zero point 0.5 and press OK. And I'm going to simulate this and you're going to see what I mean here. There'll be a problem now when I come to machine this. Let's just skip to the very end of this now. You can see here, if I look at that, you see this cone of material left here. So that cone of material that's left there is basically because the chamfer tip has been able to go further into that corner than what the end mill could. You can see the same effect here. So the chamfer tip is able to go around. I mean, not is that only really bad for the chamfer tool, you're going to get quite a bad looking part. So with the chamfer tip offset set to 1.6, it's pushing that chamfer tool down further into the part and in effect increasing the diameter of that chamfer tool. And what we get then, if we simulate, is we get the chamfer tool following a very similar profile then to the contour. So we can see now we've got rid of that big cone that we could see before. That's gone now. So again, little things like pushing that tip offset down, making your chamfer tool bigger, making your chamfer tool act like the same diameter as the tool you're cutting with. So again, this is a bit of a weird scenario here because I'm intentionally machining this part wrong. There's no way I'm going to cut these tiny corners with a 4mm tool. But that's fine by me. I know exactly what I can get away with on this part. You know, in a different world, I'd have to potentially go back and do a design change. But as we're making these parts ourselves, we're more than happy that we want to make these parts manufacturable. We want to make sure that we can make these 210 laptop stands as easy as possible and ship them out. And these are the sorts of problems that you will come across, and you'll need to basically look at how do you get around them. So yeah, hopefully that answers some questions there, Spence, about the chamfer tool.
Yeah, absolutely. He's come back and he says, okay, so you match the diameter of the slotting tool to the theoretical diameter the chamfer will have at its upper engagement.
Exactly. That is far better than I could have put it. That was embarrassingly better than I put it. So thank you very much, whoever that was. Much appreciated. So let's have a quick look now at our Operation 20. So I'm using something here called expanding mandrel clamps. I mean, say that 3 times fast. So what we've got here is a clamp that I put my part over. I then tighten up this central Allen key here, or the central bolt, and that's on a wedge, and it forces those dark portions of the clamp out and grips my part. So they're expanding mandrel clamps, and I've got 6 of them, 3 on each part. Why have I used those? Well, the big reason here is I didn't want anything protruding over the top edge of the part because I've got a facing pass that's going to come all the way around here. So I've got that facing pass that's going to come all the way around. I did not want like bolts or clamps over that surface because I then couldn't face that off. So that's simply why I've done that. You know, also this fixture here, again, the eagle-eyed viewers might have seen I've got this hole and this hole here. That's because this fixture is universal and makes all 3 sizes of laptop stand, 120, 140, 160. So if I hover over the right place, I should be able to get the other one to show up. So what you can see there is the shadow effect that I've got turned on there to select the hidden bodies. So you can see the different parts on there. So the top portion there to that portion there is identical for all the laptop stands. So they're the same center distance. So they stay where they are. And then it's just this bottom foot that changes for each size. That's why I've got those 2 on there. So you can see simple things like having 1 fixture rather than 3 means I haven't got to keep taking fixtures on and off the machine all the time. Hope this is making sense. Again, I'm not the best fixture designer in the world. I'm far from it, but this was just the design approach I wanted to take for this one. So how did I set this fixture up? The first thing I had to do was make sure it was flat. So I got a dial test indicator or a clock. Someone's taken it away, so I can't show you which one I used. And I ran it up and down this edge. And this aligned my y-axis. So a little challenge in the chat for you now. Why did I run the clock up and down the y rather than across the x? So come on everyone, you've got about a minute to put your answers in here. Why did I run my clock across the length of the y rather than the length of the x? I'll visit that in a second. So Spencer, get the answers ready. What I did then was I machined a hole in the center and I used that as my datum. I mean, look, I've even been as fancy as engraving op20, show my X and Y, and show that it's under G55. And that's just not in Fusion. We'll look at it later. It's on the machine. I engraved that into the fixture. Little things like this, again, showing the power of integrated CAD-CAM. I mean, you might think that's just for show, but imagine if I'm going to ask someone on a night shift to set this up. How much easier is that going to be for them? There's going to be no risk of them mixing up X and Y or putting the wrong datum offset in there. So little things like this make a real big difference when you're doing fixtures. Go on, Spence, hit me up with those answers, or are they still coming in? Why have I gone along the Y rather than along the X?
So the 3 people have provided answer, and it's all the same. So you've done the Y because the Y is longer and therefore provides a more accurate result.
God damn, everyone's clever on this call. I was going to hopefully catch them out with that. That is exactly what has gone on there. You've got to think, if I've got an error across a distance, the longer I measure that distance for, the more error I'm going to read. So the more accurate I can make the fixture. Damn, that was annoying. I was really hoping to catch people out with that. People saying that because you've chosen the X in the setup direction in Fusion and all sorts of stuff like that, but no. Anything
So
else
to
from this
call,
one?
well, there's one question, but to call out the people that got it right, there's a Stuart, V8 Dave, and KMS, who all said, who all provided the answer there. I do have a question for you though.
Go for it.
Um, well, more of a statement, I guess. Razor Music. I said just touch probe and rotate the coordinate system. Easy peasy. Any thoughts on that?
Yep, I'm not going to get too much into this, but we've got a Haas VF2 here with a. I mean, mate, you've talked to me about probing, and Spencer knows how dangerous that's going to be. The big one on here is the probe on our machine is accurate to 30 microns. I want it more accurate than that. As simple as. I want this more accurate than 30 microns. We've actually got, we're quite lucky, we've got lots of equipment. There's a different, I should stop talking about probes. There's two different types of probing electronics, kinematic and strain gauge. Kinematic probes are like switches, they're on and off. That's the switching mechanism inside the probe. And then strain gauge probes have strain gauges in them and give a much more accurate result. You can get down to sort of like, 3 microns rather than 30 microns with a strain gauge or a kinematic probe. I used a 1 micron dial test indicator across the length there. So yes, I love probes. Probes are actually my job at Autodesk. I'm the process specialist that specialises in inspection on machine tools. I try and use probes at every point I can, but there are some points where you can't beat a good old-fashioned dial test indicator, and that's what I did there. And again, another one of that is I'd have to update that whenever I moved it, and it was just the way I wanted to do it. So really valid point. I could have probably used the probe, and I wouldn't have noticed the difference. I also like to not forget the good old-fashioned manual skills. Like for example, I actually just as a test myself, I set that hole up with the probe, and then I did G59, and I tried to do it with my dial test indicator because I don't like to forget the skills that you sometimes need. We can get quite lazy with probes. Yeah, we've got some apprentices here. Won't mention any names, Josh. That use probes all day long, and sometimes then when they see like we've got manual tool length setters. They've never even seen them, and I think we need to sometimes go back a bit because what happens when you inevitably snap the probe like I did once at a show, and then you need to go back to knowing your manual skills of how to set things up. I hope that wasn't too much waffle then.
Perfect. I love the call. I love the Josh call out.
I didn't say anything. What are you on about? Anyway, so that's what I've got there for my Operation 20. Let's have a quick look at the toolpaths I've got there. I've got the facing toolpath. I've then got the roughing toolpath. So that's going to go around now. You might notice these are all circular patterns. Simply, it's a lot quicker for me to select one lot of these contours and then put that into a circular pattern than what it is for me to select the contours on both parts. Just as easy as that. You've got to think I've got the outer contour there, all these inner contours. It's so much easier for me just to pattern this rather than just to select all those contours. That is the only reason why I did that. So we've got the 4mm end mill. I'm going around there, and then I've got this thing called tab positions. So the tab positions are the positions that the tabs are going to be in. So we can see here these little tabs, and I mean this is absolutely golden in Fusion. All you do is you tell it where you want the positions of the tabs, the tab width and the tab height. Now those of you that have been watching will know that I've machined 2mm from the other side. So 3.1mm tab height is actually 1.1mm because 2mm of that's already machined from the bottom. And then Fusion is absolutely magical in the way that it lifts the contour around the part. You see that move going up, around, and down again? It's done that all for us automatically. I mean, how good is that? So that's put all those tabs in for us automatically. You can see another one here where it's gone up, around, and down again. The reason why you can't see the blue line underneath here, by the way, is I'm overcutting. I'm cutting down below the surface. That's just good practice to make sure you're not basically cutting size for size on that fixture, because you might get a burr thrown up underneath it. If you cut below the surface, you know you're going to get a nice clean machine edge. So that's what these tabs are. I mean, that is a brilliant function. All you do is you select points around the part and it puts the tabs in for you. I'm then going to chamfer everything. And what's going to happen then, I am going to stop the machine. I'm going to quickly remove all the tabbed components. So they're that weak, I just get a screwdriver and I just tap on them with a hammer and the tabs snap off. But we'll see that in a second. We then got some lettering that we put on. So I made this one for Alice. Again, we're sending out these to people. You could have one of these on your desk. And then I then run the final contour all the way around the part to take off that stock to leave that I applied, both on the roughing pass, on the roughing contour, and on the roughing contour on the other side. So what I've got then is all these edges here are finished in one toolpath in one setup. So I don't get any step in between. Let me just quickly show you that on the part here. So you can see here's the part. There's no step at all there because it was only one toolpath that created these edges. So you can see how valuable it is to really look at your parts, look at applying stock to leaves in certain scenarios to then do a full clean machining pass in other scenarios. How are we looking, Spence?
We're looking good. We're looking good. Solomon's really shows on the blink, so he needs some of the manual skills, so he appreciates it. I asked if people had used tabs in Fusion before, and Solomon actually used them on Monday. So it's brilliant for the parts that he's making, all parts such as these. And then we've got a question: why use tabs when the part's in the fixture?
Because, okay, it's a really good thing. Let me go and grab, let's swap to another camera actually, have a look at the other camera. So, 1 second, let's flip back to that camera. Again, sorry everyone, but I don't want to risk having people near me because for my safety and theirs, so I am cameraman and presenter. So, right, we've got these tabs here now, and they're holding on these blocks of material. I don't want to waste time and effort machining out all these blocks, but I also don't want to send out parts with, so if I see here I've broken these tabs off, and there's that little bit of the tab left on there, and that is sharp to the touch. And I don't want to send out parts that are sharp to the touch. It's not good practice. So what I want to do is I want to run a contour pass around the whole of this afterwards. And if I was to run the contour pass around that now, these would come loose and inevitably hit against my tool and snap my cutter. Now I can tell you that because the first few I machined did exactly that and I got through two 4mm mills far too quickly. Because I thought, oh, I can do that without tabs, they're not going to move, they'll just come out and they'll come loose. No, they don't. They get trapped against the cutter, they vibrate in the pockets, and they will inevitably snap your cutters. Again, I love a few stories on these live streams. The place I used to work at, we did a lot of automated cells, and one of the maintenance engineers, the best advice he ever gave me is never trust gravity. So if you've got parts dropping off or parts doing something or like this, you want something just to stay still when it's loose, don't trust it because it won't. If you want a part to get from there to there in an automation cell, you pick it up and move it. Don't trust us pushing it off and gravity will do its work. Never trust gravity. Again, I should really stop with all these little stories, but hopefully it makes things a bit more funny for everyone. So let's actually have a look now at our machine and what's going to go on. So here we go. There's our parts in our cell. Let's get the camera right in there actually. Let's really have a look at what we've got going on here. So you can see my operation 20. Again, I wasn't lying. I have machined the X and Y, G55, op 20 in there. And hopefully you can see there are the manual expanding mandrel clamps. So let me take those off for you now. Hopefully I'm not going to cover the camera up too much. Just use a little Allen key on here. So these are two M2 threads. The threads are absolutely tiny on these clamps. So what I did was I drilled out the centre hole as an M6. I then put an M6 bolt in there, and I then drilled and tapped it M2. And the reason why I did that is because this is an aluminium fixture, and I'm making quite a lot of parts. I think the aluminium M2 threads would have gone over time, where a bolt is steel. And also, what I can then do is put a stud extractor into the threads, and I can extract my effectively my homemade helicoils, if you will. If you don't know what a helicoil is, Google is your friend. So there you go. There's the two parts. They've now been taken off. What I'm going to do, let's zoom out for a second for you all, is I get my operation 10, and let's quickly undo that. I'm then going to, okay, sorry about this, might be a bit loud for people, but it's a real shop, real times. Let's give that a quick blow off with compressed air. And I'm then going to flip that over and pop that in to my Operation 20. Oh, I've still got some swarf on there. Again, when you're making fixtures, I mean, what I should have probably have done, you can actually get little caps that you put over heads of bolts. Those are my M12 bolts there that I bolt this down to the machine bed with. And you can actually get caps that you put on those. If I was in a proper production environment, I definitely would cap those off because they're a swarf magnet. And you definitely don't want swarf because I need this to sit down perfectly flat on my fixture. So, a machinist's best tools are their ears, not their eyes. Hopefully you could hear that, a real dead sound. If I were to pop my Allen key underneath, however, again, sorry if this is loud, everyone. There you go, real loud ringing noise. I know that is not down flat. And I actually did this earlier again, I made about 30 today, and I gave it a quick tap, the sound just wasn't right. And obviously I had a bit of swarf underneath. So I took it off, I could see my swarf, and I cleaned it off then. Because my datums here are these holes, they're giving me my X and Y, and then that face is giving me my Z datum. So I need to make sure my datums are nice and clean so my part locates correctly. Again, work holding is all about datums and actually holding the part. And in my opinion, sometimes your datums are more important than actually the strength of holding the part. Because you can look at your toolpaths, you can apply less force, but if your datums aren't correct, well, your part's going to be scrapped regardless. That's probably the quality inspector coming out to me that cares more about the size and positioning of geometry rather than how strong I hold it. How are we looking in the chat, Spence, while I faff around putting all these bolts together?
Mate, we're looking brilliant. People absolutely loving it. Few questions for you as you do your bolts.
Look at this for multitasking.
You said, yeah, absolutely. You said that you pause the machine after
Yeah.
after the tabs. Do you add that to the code or do you pause the machine manually?
So it's not in that Fusion document, but I put a manual NC in there. So I put a manual NC to actually pause it. That's what I've done on the production ones, but I've been playing around with that file. What you see there is I've done the 140 and the 160 mil ones, and that was the 120 mil file I'm looking at. So that's not 100% finished yet, but I just wanted to show you what I was working on today, everyone. So here we go. Let's move that camera around a little bit. And right, let's run this. So let's find the right program. This is the 140mm Operation 20. I always start the program slow because even when it's not live, the last thing I want to do is plow a tool through the machine bed because I would never live it down. So here we go. We're going to come in with our facing cutter now. So I'm just using the hand wheel here as the potentiometer on our HAS. Most machines have some form of potentiometer where you can control the feed rate. Once I'm happy that it's in the right place, that's when I start the cut. In my experience, 99% of machine tool crashes happen then. They happen because you've got the wrong tool selected, the wrong tool length, or the wrong datum selected. Don't get me wrong, there are some problems in the toolpath that you can get, but in my experience, most of them happen actually at the start. Really sorry for the coolant on the screen there, but sorry, this is life. So we can see here that we've got this going around. Let me quickly grab a towel to dry my hands off because I'm feeling a bit oily on the hands there. So we've got a nice facing pass going on. Probably can turn the coolant off that little bit on there. It's not, so you're taking I think about 0.3 off on the facing pass. And then the next thing we're going to do is we're going to do that slotting we spoke about. So what's everyone been making this week? I'm just basically trying to kill a little bit of time here while this machine. So what has everyone been making? We want to hear that.
There's
Spencer's thinking you could have been a little bit more professional there, Rich.
no doubt. Professional, always the epitome of professional, mate. Don't worry about that.
Right, let's clean this screen off
Couple of
for everyone.
questions for you.
Yeah.
Couple of questions coming in. Do you have a relief on your fixture so that your contour doesn't rub against the fixture floor?
Yes, I do exactly that. Sorry you can't see because I don't want to take that part off now I've put it on, but I do. And back when I was training an apprentice to once, he actually programmed that in. And I went, why on earth are you doing programming a separate toolpath to do that for the first time? Just run the machine, it will cut it once, and then it'll miss it every other time afterwards. I'm quite a big advocate for if something's in the way and you're happy for it to be cut, we'll just run the toolpath. Do it a little bit slowly. You'll cut it out the way once, and then it's not there again. So yes, you might have seen back in Fusion that I went down 2 millimeters down, down from the bottom. So what will happen is the first time that it runs, it will cut the fixture, and then every time afterwards, the fixture's already cut. What I actually do, again, because I like to make things just right, is on the first pass I go a little bit lower, and then I lift the tool up a tiny bit, only by 0.25, for every one then afterwards, because I don't want the tool to be rubbing on the bottom. It's quite bad for the edges to leave it rubbing. What I'm using on here as well is a ramp in the contour. So in the contour selection, in the contour toolpath, in the linking, the very last tab, there's a ramping one. And what it does is it ramps around the part. I've got, I think, let's have a quick look in Fusion again here. What angle have I got on that ramp? So let's have a quick look in Fusion, everyone. So what I've got here, that's the chamfer, that's the contour. Let's edit that toolpath, have a quick look. So this was the ramp that I put on. I've got a 6-degree ramp around there. So what you can see here is those red lines are around the part. They're going down, and I'll do this in 2 steps. I tried it in 1 step, and my tool life was horrendous, so I had to go in 2 steps down the part. Yeah, so that's what we've got on there. Let's jump back to the machining footage. So we can see the part going around now. It's going around. You might even be able to see in a second where it lifts up to do the tab. So let's quickly keep looking. It should do at the end of this straight. So it's coming down. Come on. Come on. Keep coming. Keep coming. Keep on.
Drum
So when it
roll,
gets to the end of
please.
this foot, it's going to, watch it, it's going to lift up and lift up down again. So that made the tab then. So that was lifting up around that tab and going back down. So hopefully you're getting what I'm saying here, and it's not just some Englishman rambling about for 50 minutes. Yeah, hopefully you've got that.
It is an Englishman rambling, but we all get what you're saying, absolutely.
Oh, thanks, Ben. That was
the one big call out. So we've got a guy called Matt DLR or Matt Delarue, who is one of the top 10 contributors to the forums. He's joined the call. I spoke to him live earlier in the week, and he gave us some really good feedback. And he's asked the question, is there a rule of thumb for how big to make a tab? I guess it's to do with material and thickness.
It's as small as you can get away with. So what I did was I start off with a size, and then every part afterwards I reduced it and reduced it and reduced it until I was worried that it was going to snap during machining. The tab was. So the tabs you want to be as small as possible, but then of course they need to be strong enough to hold on whatever it's holding. So I'm quite lucky here because all the tabs are doing is they're holding the loose waste bits of material to stop them from flying around and hitting the cutter. I'm not using the tab to be strong enough to hold my actual part I'm machining. Hopefully that makes sense. If you're doing that, they'll need to be quite strong because you're applying load to what is the tab structure. But here, all the load is being applied to the part that's fixtured down with those expanding mandrel clamps. There's no load being applied to the components that are held on with tabs. So for me, I wanted them as small as possible, so they're as easy to break off as possible. Yeah.
Brilliant. Hope that answers your question, Matt. And then one last question. Do you leave stock in the pockets with tabs and clean the inner contour in the fixture?
I'm
Let me
not
read that
sure.
again.
Go for it again.
Do you leave do you leave stock in the pockets with tabs and clean the inner contour in the fixture?
I'm not 100% on that, but
We
what
might
I'm
need
going
to
to
get we
say,
might need to get a little bit more information
yeah,
from
let's
raise some music.
let's jump back in Fusion while we might be getting some more information on that. So what I've got here again is both the inner and outer contours have been cut with the 2D contour and the tabs. So I'm left with tabs in the middle and tabs on the outside. So both inner and outer contour are tabbed to make sure that the outer chunk of material doesn't go flying around, and also the inner pockets of material doesn't go flying around. I mean, this one here is that small. I could probably machine it all. Same as that one there. I could probably just trachoidal it all out and do a pocket clean or adaptive clearing. But I like the 2D contour tabbed approach. It works nice. I think it's putting a low amount of load on the tool as well. So that's what I've gone for here. So, I mean, everyone, I'm happy with what I've shown you today. Hopefully, this has explained how to do a second side of a part. Again, what you need to consider when you're machining the second side of a part is datums and physical holding of the part. You need to look at the areas you need to access for the first operation versus the second operation. I mean, I've done parts where that need 7 operations until they're finished. Things like cylinder heads are a bit like that. So you need to look at how many operations do you think you need, the fewer the better, and then datums between those. It's very common to make datums in operation 10 and then use them in all those subsequent operations then. Because I think every time you reference a datum to another part, there's going to be a discrepancy. It's a fact of life. So you need to make sure that you do that sort of, you don't want to make a datum in operation 10, reference that in operation 20, then make a new datum for operation 30, then make a new datum for operation 40, because you'll get a stack up of error across the part. So, yeah.
Got a few final questions coming in for you, Rich. Just before we wrap up, not so much for a question, but Solomon is making stamping plates from A2 steel.
Ooh, nice.
Um,
A2, does it mean
uh,
stainless steel?
maybe, maybe.
I think A2 is stainless steel.
KMS knowledge, Rich, showing you knowledge there. KMS, would it make sense to put a tap at the start or end of the contour to have the least amount of force on the tabs?
Say that again, Spence.
Would it make sense to put a tab at the start or end of the contour to have the least amount of force on the tabs?
I get them. It's at the
I
start and
think he
end
means
of the
if got
pass. Yeah,
yeah,
I just yeah. So I see what you mean. So
correct.
so at the very end, there's the material you haven't yet machined that's holding it on. Yeah, that would make perfect sense. I didn't think of that. A lot cleverer than I am out there. So yeah, that would have probably made a lot of sense. What you'd have had to have done then is look at where you want your tabs and then put a tool start position at the same position as your tab. So that's what I could do. I could put a tool start position and then also then a tab. So when it comes back round the full contour, of course we always end where we start. So when it does the contour then, you start on the tab, you go all the way around and then you end on the tab. So effectively you've got a massive tab until the very last second where your contour cuts it off. Brilliant idea, and I'm going to use that in the next one. Thank you very much.
Brilliant. Yeah. Shout out to KMS FPV for that one. And then you got Stuart Duncan. He says he's making race car suspension parts this week, all from 6082 aluminium, and then he anodizes them.
Ooh, that sounds nice.
Uh,
That does sound nice.
what cycle time for op one, op two, Rich?
12 minutes op 10, 13 minutes op 20. So about 25 minutes all in for both ops, making 2 parts. So to be honest,
And last question.
I'm probably going to push that 4mm a little bit harder when I get some more confidence in it. But at the moment, I'm being quite conservative. I'm running 10,000 RPM, 700mm a minute.
Brilliant. And then what are the working dimensions from Mamadou of the
Working
part, I guess?
dimensions. I'm not quite sure what we
The,
mean
the,
there.
the finished dimensions. How big are the parts, Rich? How big are the
Oh,
parts, I
okay.
guess?
Well, I make them out of a 300 by 160 billet, and I get 2 parts out of that. So again, it's a bit like a triangle. So you can sort of see there what I get left. So that's what I get left out of the part. There's my steel rule. So let's have a quick look at the 140. So this is the laptop stand again. Across we are 240 mil, and then down that way we're 130. So again, I have 2 parts, and I put them like a triangle together. It was the best way I could look to not waste material. And again, because I'm engraving potentially your name or your slogan or whatever 10 characters you want in these, I wanted to make them in pairs, just to make the engraving a bit easier. Now we've got about a minute left until this one's finished, so please stay online and you'll see this one finished and you'll see how I break the tabs off. So I think that'll be quite interesting. Again, I just use a screwdriver and a little hammer, and I literally just tap those tabs off and they just break away instantly. So yeah, are we all right on
Mate,
the chat,
yeah,
Spence?
the chat, yeah, people are absolutely loving it. Solomon saying it's really informative, really good live stream. Carl, I believe, from South Africa has just joined, I think. So hello, where have you been? You've missed all the good stuff. Just in time to see the tabs being broken off, though.
Yeah, definitely.
So it's nice to have you back.
Please, like, I know
And you've
this isn't.
got a well.
Go on, Spence. Sorry, I should stop interrupting you.
No, absolutely not. I was just going to say you've got a congratulations from V8 Dave, who's saying well presented and good information all around. So well done,
Ah,
Rich.
cheers, thank you very much. Please let us know. I mean, again, these aren't extremely polished because I'm only the one person here. Let us know if you want to see more on machine stuff. We can try and arrange this. Again, this one was how to machine the second side of a part. This was suggested in the last live stream we did, so let us know your thoughts. Can't do them every week like we did back at the start of the year, but whenever we've got a day free, me and Spence love to do these live streams. So please let us know what you want to see. It saves me a job thinking of them. So let's quickly
If
blow
you
a
were
little
to
bit of coolant off.
if you were to give one tip off the back of machining this part, Rich, what would you give?
Oh, don't machine 250 laptop stands. The tip I would give, to be honest, it'd be the tabbing. I waste a lot of time with broken tools at the start because these bits of material were coming loose and snapping my tool. So if in doubt, use the tabs. Never let a piece of material come loose when you're machining. Be that you're facing the top off something, or be it like this. Never let a chunk of material be detached from the part because it will inevitably cause you problems. Yes, you might be saving a bit of time in the short run, but imagine how much time it takes to replace a broken tool and the cost of that. Right, so you can see here this big bit there. All I do is just tap, tap, and there we go. It's out. Easy as that. That block of material is now out. That goes straight in the swarf bin. Pat can clean that up in a bit. Tap, tap. I just go around it. I mean, to be honest, I can lever these off, but as I'm shipping these laptop stands out, I don't want to be any marks on the side of the part. I could. I started off actually by undoing all the clamps, lifting the part off, and just snapping them off. But then it was taking me longer to undo the clamps and do them all back up again. Plus the fact that you risk um, not having it located in exactly the same place for the final contour pass then. So what I do is I just go around, knock all those tabs off, missed one. And what you can see now is look at that. Look at that. Crikey. I mean, that's something to behold, isn't it? Quickly collect all these. Again, you don't want them loose. Don't put them down in your swarf auger, or else you'll be spending a week trying to unjam your swarf auger. Just lift them out, nice and easy. Like, as he says when he's wrestling with one that he can't get out. Lift those out. There you go. There's the part. Again, what I just do now really quickly is just tap down on the clamps, listen for that dead noise. I just want to make sure that I haven't disturbed the part. And now I just press cycle start in the program again, and now I run the finished contour pass. So let's just quickly watch this one go, and then I'll let everyone have their day back. I'm going to turn the coolant off so you can just hopefully see that little contour pass going around now. Let's get that camera a little bit closer. Whee.
Rich, we've got a challenge in the chat for you.
Go on.
So the challenge is
Can I
to
not talk for an hour? No.
yeah, to do a similar live stream, but with a more complex part: a mold, core, and cavity.
Okay. Well, you're
There's your
pushing me
challenge
there.
for a feature live
Um,
stream.
yeah, I'll have to think. The big one for me is time on the machine because people don't like the fact I use the machine all day because it's meant for validation and testing, and I say no, I want to use it for a live stream. So we'll see what we can do. I'll see what we can do. If you've got a part that's machinable, like a cavity mold tool, whatever that was, send us the CAD over. Chuck it in the forums is the best way to get in touch with us, and I'll see what we can do. Again, I can't really spend a day making a part. This is nice and easy because they're already on the machine. I have got to balance up time and things on the machine. So thanks everyone. I really hope you've enjoyed the session today. I hope you haven't felt like it was just two Englishmen having a chat for an hour and you didn't really get anything from it. I hope you feel like you have got something from it. We do appreciate all the feedback and see you again soon. Don't forget to join my AU live factory experience. I want to be sending as many laptop stands out to the viewers as possible. We are doing it as a random draw. It's just it's we can't risk doing first come first serve because of time zones and everything. So it's just gonna be a random draw. 210 people are gonna get laptop stands.
Absolutely, and I'll be there in the chat, just like the live
Yeah,
stream. So
Spencer's in the
come
background.
check us out.
He doesn't get any of the glory. He just sits there and does all the
Absolutely.
work.
Yeah. Still have to get up at 7 a.m. though, don't I?
Yeah, I think about 5:30 though.
All right, it's not a competition, Rich.
Okay. Cheers, everyone. Really
Yeah.
appreciate all your time. Speak to you soon. Bye.
Thanks, everyone. Bye bye.